Hello everyone, and thanks for joining me on this discussion on discrete random variables. And this is the focus of Module 2. We're going to be learning first about random variables, and specifically we focus on discrete random variables. So we will be talking about concepts such as central tendency and variability, and we'll learn about the difference between discrete and continuous random variables, as well as computing probabilities regarding random variables. Also computing mean, variance, and standard deviations of discrete random variables. As always, you can refer to textbook, these sections, for more discussions on the same topics and looking at problems and various examples that they have. Let's jump right into it. Random variables. What they do is they summarize a random experiment for us using numerical values. So what exactly they do is they assign a real number to each outcome in the sample space of a random experiment. You can take this random experiment, for example. Assume that there is a jar with a green, blue, and red ball in it, and we're drawing two balls from the jar with replacement, basically placing the first ball back in the jar before drawing the second. Essentially, we're looking at a jar like this, and when we are drawing two balls from this jar with replacement, the outcomes that they can happen is you either grab these two, you grab these two, or these two, or the same ball, basically blue blue, green green, or red red. Here we are defining a random variable x, and we define it as observed number of green balls. So now that we have gone through all the outcomes that can happen, we know that x, this random variable, can be 0, can be 1, or 2, meaning that the two balls that you're grabbing out of this jar can have 0 green in it, 1 green in it, or 2 greens. And I want you to think about what those outcomes are. Which outcomes are associated with different values of this random variable. So if I ask you, when x is equal to 0, what are those outcomes that give me x of 0? What are those? Same for when x is equal to 1 or when x is equal to 2. So pause the video, take a moment, and write them down. Just to give you a heads up, when x is equal to 2, meaning that observed number of green balls is equal to 2, there's only one outcome that gives you that. That is green, green. So now you guys work on when x is equal to 0 or when x is equal to 1. So when x is equal to 0, the outcomes that result in that is either blue blue, red red, red blue, or blue red. So 4 outcomes will give us x of 0. And x is equal to 1 is when we have 1 green in our outcomes. And only 1 green. So green blue, blue green, green red, and red green. So 4 outcomes there. So here you realize the relationship between the random variable and the number that it gets with the outcomes in the random experiment. And that's the job of a random variable, to assign numbers to the outcomes in the random experiment. And the good thing is, defining a random variable is up to us. I could define another random variable, let's say y, and that would be observed number of red balls, for example. Some of the key definitions and characteristics of random variables. First is the range. What is a range of a random variable? The range is the set of all possible values that a random variable can get. For example, here, this is the range of this random variable x, 0, 1, and 2. So from 0 to 2 is the range of this random variable. set of all possible values of a random variable. We talked about discrete random variable versus continuous random variable, and the difference really comes down to the range. When the range is countable, the random variable is discrete, and when the range is non-countable, the random variable is continuous. You know, the random variable that we had here is obviously discrete. There are 3 numbers that this random variable can get, and you can count them. They're separate. There is no value between 0 and 1 that this random variable can get. There is no 1.5. But continuous random variable, you can think of, average temperature of any given day. And that's a continuous random variable because average temperature can be any number. And between any 2 temperature that you pick, there are millions more temperature values because we have decimal points. So in those cases, we have continuous random variable. But the focus of this module is on discrete. Let's take a few very simple examples. For example, when you're flipping a coin, this is a random experiment. It has 2 outcomes, heads or tails. You can assign numbers to those outcomes, and that can become your random variable. So x, for example, let's assign, 0 or 1 to them. It's a binary random variable, essentially. If it heads or if it's tails, it's equal to 1. Flipping a coin 3 times. Well, when you're flipping a coin 3 times, there are 8 outcomes in that random experiment. And you can assign a separate number to each of those outcomes if that's what you're looking for. But typically we define a random variable that is meaningful. For example, here you can, define a random variable x as, number of tails, right, or number of heads. If I define this as number of tails, the range of this random variable would be from 0 to 3, right? Maximum you can get 3 tails, minimum 0. So that's the range of this random variable. Or throwing a die. I can define a similar random variable that I defined for flipping a coin, a binary random variable. It's equal to 1 if you get 6, and if it's equal to 0 otherwise. Obviously, the probability of 0, now it's more than probability of 1, because 5 outcomes results in x equals to 0, while just 1 outcome out of 6 results in x equals to 1. But that's fine. It doesn't have to be equally likely. Or I can define another random variable, y this time, and that would be the value of the die's face. And in that case, the range of y would be from 1 to 6, right? There are 6 numbers that can be assigned to y, this random variable. Or you can think of, random experiments in engineering or in real life applications. One of the common applications is in quality control. For example, you're observing the quality of 50 brake pads, and you can define a random variable here that is, for example, its number of defective pads among those 50 pads. And every time that you repeat this experiment, you're going to have a different number of defectives, and it changes randomly. So it's a random experiment, and you're defining a random variable of your interest, and that's the number of defective pads. And for this random variable, the ranges from 0 all the way to 50, right? It can be all of them or none of them. Observing the occurrence of tornadoes in the Midwest, well, we know that the occurrence of tornadoes really, happens in a random fashion. And you can define so many different random variables here. If you're interested in the number of tornadoes, for example, in Oklahoma, that's your random variable. Number of tornadoes in Oklahoma in a given year, or number of tornadoes that caused damage of more than $50,000. That's another random variable. But make sure that your random variable that you're defining can get a numerical value. Or when you're measuring the time between two customer arrivals to a bank, that time between arrivals is totally random, and it changes between any two consecutive arrivals. And that's actually a very common random variable that we use in modeling service systems or manufacturing systems, especially in simulation modeling, because it's important to model the arrival of, for example, customers to a bank, or products to a manufacturing facility, or and trucks to a distribution center, and things like that. So time between arrivals is actually a very common random variable. Or measuring the life of a light bulb. And in that case, the time to failure is a very common random variable that they follow in reliability applications mainly. Time to failure, or it's called TTF. So I hope these examples and the definitions that we covered help you to understand the idea behind random variable. In simple words, a random variable is assigning numbers to the outcomes in the sample space of a random experiment. And we can define random variables in so many different ways depending on what we're interested to study in that random experiment.